Good morning everyone. Today we will start with our first experiment, finding out alternator regulation by direct loading. So in this experiment we are going to find out the regulation of the alternator by directly loading with the resistive load. So these are the machine details. We will find an alternator which is having a rating of 5 kVA, 50 Hz, 1500 RPM, 7.8 ampere. Excitation as 220 volt DC, 1.2 ampere. Then we are having a DC motor which is acting as the prime mover. The DC motor is a 7.5 HP motor with 1500 RPM, 230 volt DC, 30 ampere. Excitation is 230 volt, 1.5, 1.1 ampere. So we have done the connection of alternator regulation by direct loading. The connection has been done by our lab staff Venugopal sir. So we will start with our DC supply from here. This is our DC supply. Okay, this DC supply is connected to this 220 volt DC input of the control panel, and through this two fuse and through this knife switch the connection will directly come to the L point of the 3-point starter. When you analyze this control panel, you have to be having your soft copy of the circuit diagram with you. Then only it will be then only you will understand how this connection is done. Okay, when the knife switch is on, the DC supply will be available on the L point of the starter. You are having a 3-point starter, L for line, F for field and A for armature. And in this internal connection, some connections has to be done. So in this one, you will have A and A are connected together. This is for our connection as such. Then we are having field connection. Field connection, what we are going to do is that we are having an rheostat connected in series with this field winding. So if you take a field connection F, it goes directly into the rheostat, then it goes to F. Here it goes to the F connection here. Like that the field connection has been done. Then we are having, if you observe the circuit diagram, you are having AA. That is, armature is represented by one terminal A, the other terminal is AA. This AA and FF are actually shorted by a wire. This is very much clear in your circuit diagram. Then you are having this FF. FF is then is directly going to the negative terminal of the DC motor. So here this ends up the DC motor section, or you call it as a prime mover section. Now the remaining section that you see on the right hand side is the alternator section. Okay, this alternator section will have two things. First one is stator and other one is rotor. Stator is known as the armature, rotor is known as the field winding. So when you switch on this particular switch, main on and off, the DC supply is provided to the field winding. The mechanical coupling is there between the DC motor and the alternator. So mechanical input is directly given through the shaft, and if you on this main on, the DC supply is provided to the field winding. Then there is one more internal connection that has to be done. Here you are connecting R1, then you are connecting Y1, then you are connecting BB1. This should be done internally. Okay, then there is a voltmeter. Which you see here, which is used to measure the phase voltage. So what you are going to do, you are connecting a voltmeter across R. This wire is connected here, and the other wire is connected across a neutral. This thing which you see on the left hand side, this N is not neutral, it is negative. This N that you see on the alternator side is actually the neutral point. Okay, so you are connecting a voltmeter in between. Then you are having the field winding section. So here in this control panel, the field winding can be controlled by using this knob. Okay, this is the field winding of the alternator. So the field winding can be varied. That means the rheostat connected in series with the field winding of the DC motor can be varied by varying this rheostat. Okay, and you need to measure the field current of the DC motor. Not the DC motor, field current of the alternator, excitation field current. That you can measure using an ammeter, which is a DC ammeter. You can see a mark here below this A. That means that it is a DC ammeter. So you are connecting in series. With this field winding. You can see here. Okay. Then you need to have a 3-phase load. You need to have a three-phase load, you need to have a three-phase load which is known as a resistive load bank. Okay, now coming to this, we are having three terminals for this alternator, that is known as R2, Y2 and B2. We are having three wires. These three wires are going to this resistive load. So as to measure a particular current, means a particular phase current, what you do is that you connect an ammeter in series with this particular resistive load. So you are from R2, you are connecting to an ammeter. From this ammeter it is going to the load. All the other terminals Y2 and B2, they are directly going into the load. When you discuss about this resistive load, you are having different switches according to what is the rated current of the alternator, which is 7 ampere. You can switch on this one by one. Okay, and you have to look into the ammeter whether you are going to reach, because when you load an alternator, you can load the alternator till the rated current. So step by step loading can be done using this. Step by step loading can be done by using this resistive load. Okay, you are having a common switch. Without switching on this, it will not work. So you have to first of all switch on this like this, then you have to rotate, switch on. Accordingly, the current in the alternator will vary. Okay. So initially we are giving the DC supply from the DC bed, and with the help of the knife switch we are switching on the DC supply, and with the help of the 3-point starter we are going to start the motor. Okay, then the rotor position is moved from maximum to minimum position in a very gradual way, and the speed is brought to, and the motor is started. Now we have to maintain the speed of the motor at 1500 rpm. For maintaining the speed to 1500 rpm, now the reading is 1328. So we have to vary the motor field rheostat, which you are seeing here, and you have to bring it back to 1500. So that should be done in a synchronized manner. You have to vary the motor field rheostat, bring it to 1500 rpm. Some more variation is required. It is showing some more variation is required. I hope this is enough. This perfect 1500 rpm. There will be a small tolerance limit of 5 rpm or 10 rpm. That is not an issue. Okay. Now the motor section is completely on. That you are able to see now. The motor section is completely working. Now what you have to do is that the motor section is mechanically coupled to the alternator section. So here you have to switch on the main first of all. Switch on the main. Yes, and all other switches you have to on. After that, what you have to do is that when you switch on the main on here, what happens is that the DC supply which is available in the bed is being supplied to the field section of the alternator. The field section of the alternator is having the DC supply now. Now what you need to do is that you have to vary the field rheostat. You have to vary the field rheostat of the alternator. That is what sir is going to do now, and he will vary it. That you can see here, he is varying the field of the alternator and then observing the voltmeter. Since it is a 500 volt directly connected voltmeter, what you have to observe is that this is a phase voltage. This is a phase voltage that is measured. So you will have correct 220 volt that should be measured in this voltmeter. Now it is around nearing 250. Now it will come to 220. We will stop it here at 220. I think slightly 220 volt it is going to reach. Yes. Now the phase voltage is set. That means that by varying the field winding excitation of the alternator, this is a field winding excitation of the alternator, you are bringing the phase voltage to 220 volt.
Now what you have to do next is that you have to measure the value of E0. Regulation is equal to E0 minus V divided by V into 100, where E0 is the no load voltage. Now if you observe the resistive load, the load is equal to 0. So the voltage that you measure here should be equal to E0. That will be E0, because when the alternator is not connected, the value of voltage that is measured is always equal to E0. Okay, now before that we have to cross check whether the motor is running at 1500 rpm. Just we will observe again. It is 1452. We will slightly vary and bring it to 1500. That is the first step you have to do. Some more variations required. I think that's enough. 1400, 1500, it is fine. Now it is fine. So the motor is running at 1500 rpm. The resistive load is 0. That means that the voltmeter that is showing now is showing a voltage of 220 volt. That's a phase voltage. That is E0. In regulation, E0 minus V by V into 100. E0 you have obtained. You have to record this value of E0. Okay, you have to record this value of E0. And the DC ammeter which you are seeing here is a field current which is being measured, and that value will be equal to, this is connected to 10 ampere, so it is direct reading. So this is direct reading, and that is showing a value of 0.5 ampere. That is showing a value of 0.5 ampere, and this ammeter will it will show 0 reading. Why? Because that is running under no load condition. Okay. So this is we have taken the no load reading. For the no load reading, what you are observing is that the generator is not loaded. The resistive load that is being connected, it is actually off position. In that particular condition, the armature current IA equal to 0. The no load voltage that you measure between the phase and the neutral is equal to 220 volt. The speed is equal to 1500 rpm. The field current is equal to 0.5 ampere. And the V is also 220. Why? Because the no load voltage is same as the terminal voltage. Now what we are going to do next is that we have to load the generator. So for loading the generator, you have to put the load. Okay. So that we will see in a gradual stage. Okay. So this is the resistive load. You have to switch on the main switch. Okay, and you have to load the machine. So first load is being applied. That means that the generator load is applied. When the load is applied to generator, the speed of the motor decreases. So what you have to do is that we have to vary this particular motor field rheostat. You have to bring it to 1500 rpm. It is 1450. We have to increase it to 1500. So 50 rpm you have to increase. So you have to vary the motor field rheostat. I think slight more increase is required. Some more variation is required for 20 rpm. Yes, I think we will see now. Yes, now it is okay, 1500 rpm. So you have to bring the speed 1500 rpm as well as the field current of the alternator also to 0.5 ampere. So that should also be observed here. So you see here the IF, the field excitation current of the alternator is again 0.5. The speed is equal to 1500 rpm. At that particular time you have to measure the voltmeter reading as well as you have to measure the load current. So the load current what you are observing here is equal to 1.8 ampere. We can observe it as 1.8 ampere here, 1.8 ampere. The voltmeter is showing as 210 volt. It is observed as 210 volt. Yes, it is observed as 210 volt. Why? Because it is from 200 to 250. So you are having 5 divisions, 1, 2, 3, 4 and 5. So this is actually 210 volt. So you have to observe, see here, IF is again is equal to 0.5, the speed is brought back to 1500, E0 is equal to 220, the voltage is equal to 210 and the armature current is equal to 1.8 ampere. So now we are going to load the machine again. So we have again put on the load. So when the load is applied, again the generator speed reduces and again the motor field rheostat and the tachometer should be observed. Now it is 1480. Again this motor field rheostat should be adjusted and again the speed has to be brought back to 1500 rpm. I think that's enough. 4 rpm is negligible. That can be assumed as 1500 itself. Okay. Now this field excitation of the alternator should be observed. It should be brought back to 0.5 ampere. I think slight decrease is required. Yes, slight decrease, it has brought back to 0.5 ampere. But this is by varying this rheostat. Okay, it is brought back to 0.5 ampere. It is brought back to 0.5 ampere. At that particular state, you have to measure the voltage. That voltage is equal to 200 volt. That voltage is equal to 200 volt. That is equal to 200 volt. At that time, you have to measure the load current. That load current you can take it as 2.7. That should be observed as 2.7 ampere. 2.7 ampere. So each and every time you have to record it accordingly. You have to record as field current is remaining a constant. The field current is maintaining a constant. The speed is constant. E0 remains the same. From the beginning itself, E0 is the same. And the voltage is again reduced to 200 volt for an load current of 2.7 ampere. So this should be repeated step by step till the armature current reaches 7 ampere. Why? Because the rated current of the alternator is 7 ampere. For our safety reason, we are loading it up to 5 ampere. So each and every time IF is constant, N is constant, E0 is again always a constant. V should be actually measured in a step by step manner. Okay.